Vulnerability Scanning Overview and Considerations. Before diving directly into our tools, we'll discuss the process of vulnerability scanning, outline basic considerations regarding both automated and manual scanning, and discuss both critical nuances and best practices. Vulnerability scanning. Vulnerability discovery is an integral part of any security assessment. While we prefer manual, specialized tasks that leverage our knowledge and experience during a security audit, automated vulnerability scanners can be invaluable when used in proper context. In this module, we'll provide an overview of automated vulnerability scanning, discuss its various considerations, and focus on both Nessus and Nmap as indispensable tools. How vulnerability scanners work. Vulnerability scanner implementations vary, but generally follow a standard workflow. Most automated scanners will detect if a target is up and running, conduct a full or partial port scan, depending on the configuration, identify the operating system using common fingerprinting techniques, attempt to identify running services with common techniques such as banner grabbing, service behavior identification, or file discovery, and execute a signature matching process to discover vulnerabilities. Notice that this process basically mirrors what we do during a manual assessment. As penetration testers, we may mentally execute some type of signature matching process. For example, we may remember that a particular version of an application we spot in the field is vulnerable to a remote exploit. An automated scanner, however, performs this step with the assistance of unique vulnerability signatures. Most automated scanners inspect a wide variety of target information during the signature matching process. Nevertheless, even a strong signature match does not guarantee the presence of a vulnerability. This means automated scanners can generate quite a few false positives and, by contrast, false negatives in which a vulnerability is overlooked because of a signature mismatch. However, by updating the signature database before every engagement, we ensure that our scanner has the best chance of discovering the latest vulnerabilities. This signature matching process is quite efficient and is much faster than a fully manual review, making automated vulnerability scanners an excellent choice as a first pass during an assessment and a perfect companion to a manual review. Although vulnerability scanners are designed to be relatively easy to use, there are still some additional considerations to keep in mind. Vulnerability scan results can vary based on the level of automation, whether a scan is conducted on a LAN or over the internet, and whether a scan is run with credentials or without. Refer to your lab guide for more information. Vulnerability scanning with Nessus. As we begin looking at tools, we will first focus on Nessus, a popular vulnerability scanner that supports a staggering 130,000 plugins. There are many commercial and open source vulnerability scanners with various strengths and weaknesses. The overall concepts discussed in this section will generally apply to just about any other commercial scanner as well. Installing Nessus. It's important to mention that vulnerability scanners are generally resource-intensive. Many of them suggest minimum requirements that include at least 2 CPU cores as well as 8 GB of RAM. These resource requirements won't be necessary for our example. Although Nessus is not available in the Kali repositories, we can manually download the 64-bit deb file for Kali from the Tenable website. Once our download has completed, we can install the package with apt. Now that the package is installed, we can start the Nessus D service, then return to our browser and navigate to port 8834 on localhost, the default Nessus server port. We're presented with a certificate error indicating an unknown certificate issuer, but this is expected due to the use of a self-signed certificate. To accept the self-signed certificate, we click on Advanced and Add Exception. Finally, we can click Confirm Security Exception to accept the certificate. Once the page loads, we're prompted to select a Nessus product. In this scenario, we're going to configure Nessus Essentials. Next, we're prompted to request an activation code for Nessus Essentials. Since we've already requested a code, we can skip this step. On this page, we'll paste in our activation code to continue. After activating Nessus, we're prompted to create a local Nessus user account. Finally, we need to download and compile all the plugins. This can take a significant amount of time to complete. Configuring scan definitions. In this scenario, we've selected the basic network scan template definition, which, like all the other templates, comes pre-configured with default settings. However, these defaults might not be exactly what we're looking for, and we must take into consideration our environment, our time constraints, and the target that will be scanned. For this scan, we want to run an initial basic port scan against all ports. By default, the basic network scan will only scan the common ports. To change this, we click the Discovery link on the left side of the Settings tab. From the Scan Type dropdown, we'll change the value to Custom. This will add additional configurations under Discovery. Now, we'll click on Port Scanning to configure the port range. Here, we'll set the port scan range to scan all ports. In this scenario, we've chosen a scan definition that will scan all TCP ports via a SYN scan, but no UDP ports. While this will increase the speed of the scan, we might miss crucial services running on the target. During an engagement, we must weigh the stability of the target network, the scope of the target, the duration of the engagement, and many other factors when configuring our port scan options. We also did not configure any credentials, which means that this scan will run unauthenticated, and brute forcing of basic credentials will not be enabled, which is the default for the basic network scan. Now that we've reviewed the configuration options and understand what the scanner is going to do, we can run our first scan. Defining targets. Once Nessus is installed, it's time to set up our first scan. To begin, we simply click the New Scan button. Nessus supports a number of different scan types. We recommend investigating these scan types, but for this introductory section, we'll focus on a standard basic network scan, which we can launch by clicking on Basic Network Scan. The scan configuration settings screen has two required arguments: a name for our scan and a list of targets. Nessus supports adding targets as an IP address, an IP range, or as a comma-delimited list. For this example, we'll scan the Gamma machine in the PWK labs. We'll enter Gamma Basic into the name field and the IP address into the targets field. Unauthenticated scanning with Nessus. To launch the scan, we'll click the arrow next to Save and then click Launch. Initially, the scan will have a status of running. Once the scan is finished, the status will change to completed. The scan time will vary based on many factors, including the scan configuration and the speed of the network. From the My Scan screen, we can click on the scan name to show the list of hosts discovered during the scan and the breakdown of potential vulnerabilities. Whether we scan one host or many, we can click on an IP address or host name to display the vulnerabilities discovered for that target. We can filter these vulnerabilities by severity, exploitability, CVE, and more. To display the vulnerabilities that will most likely lead to target compromise, we can click on the Filter drop-down and select Exploit Available. We'll accept the rest of the defaults and click Apply. This will display a list of vulnerabilities in groups that are defined by Nessus. While this grouping can be useful, we will click the gear icon at the top right of the table and select Disable Groups. This lists all vulnerabilities on a single page, sorted by severity. This output format is perfect for our purposes, as it displays a kind of roadmap to potential compromise of the target, with highest risk vulnerabilities displayed first. Of course, some of the entries may represent false positives, which is why it's critical to review the scan data and manually test the scan results. Authenticated scanning with Nessus. We can generate more detailed information and reduce false positives by performing an authenticated scan, which requires valid target credentials. To demonstrate the value of an authenticated scan, we'll run one against our Debian Lab client. To begin, we'll click the New Scan button. Even though all Nessus templates accept user credentials, we'll use the Credentialed Patch Audit Scan template, which comes pre-configured to execute local security checks against the target. This template will not only scan for missing operating system level patches, but will also scan for outdated applications that could be vulnerable to vectors, such as privilege escalation. Once again, we'll provide a name for the scan and set the target. Note that the IP of your Debian client will vary. Next, we'll click the Credentials tab and the SSH category. On the Authentication Method dropdown, we'll select Password, set the username to root, and provide the password for our Debian client. While we'll only use the SSH configuration for this example, we can easily review the other Nessus-supported authentication mechanisms by selecting All from the Categories drop-down menu. Finally, we can launch our scan. As with the unauthenticated scan, while the scan is in progress, the status is reported as running. Once the scan reaches a completed status, we can click on the scan name to open up the list of hosts and click on the Debian client's IP. This shows a list of the discovered vulnerabilities that may be exploitable on the Debian target. In this view, notice that the vulnerabilities are listed with patch numbers. This is because Nessus determined that the target was running the Debian operating system and executed only the Debian local security checks plugins. We can see that the authenticated scan was successful, as the scanner now has visibility into vulnerable applications that are not remotely exposed, such as Firefox. Scanning with individual Nessus plugins. By default, Nessus will enable a number of plugins behind the scenes when running a default template. While this is certainly useful in many scenarios, we can also fine-tune our options to, for example, quickly run a single plugin. We can use this feature to validate a previous finding or to quickly discover all the targets vulnerable to a specific exploit in an environment. For this example, we'll run the NFS exported share information disclosure plugin against the beta host in the lab. We can use this plugin to gather information from the RPC server on port 111 and validate if the target is exporting any NFS shares. To run a scan for a single plugin, we'll once again begin with a new scan. This time, we'll use the Advanced Scan template. Unlike the templates that we used previously, the Advanced Scan template does not use recommendations for scan configurations. This template does, however, offer a set of advanced defaults that are typically hidden or unavailable to other templates. The Advanced Scan also allows us to select individual plugins, an option that is not available to most other templates. We'll begin by configuring the scan name and targets. To save time and scan more quietly, we'll turn off host discovery since we know the host is available. We'll do this by clicking on Discovery and deselecting Ping the remote host. In addition to disabling host discovery, we can also narrow the scanned port list if we already know what port the service is running on. Since we're scanning the RPC service and we know that RPC is in fact running on TCP port 111, we'll only scan this port. To set this up, we'll select Port Scanning under Discovery and enter 111 into the Port Scan Range field. We'll also uncheck all options under the Local Port Enumerators section as well. With some of the scan options slimmed down, we can begin to select the plugins. We'll start by clicking Disable All so we can start with a clean slate. At this point, the scan will run very quickly, but it won't do much. To scan for open NFS shares, we'll navigate to RPC in the left column and set NFS exported share information disclosure in the right column to Enabled. Now that the scan is configured, we're ready to launch it. Once the scan is completed, we can click on the scan name, then on Beta's IP to open the list of discovered vulnerabilities. Navigating to the single critical vulnerability and clicking on it displays a detailed page showing all the exported NFS shares. Note that the scan also generated 2 additional info plugin outputs. These include details about the scan and the result of the SYN scan. Vulnerability scanning with Nmap. As an alternative to Nessus, we can also use the Nmap scripting engine to perform automated vulnerability scans. While the NSE is not a full-fledged vulnerability scanner, it does have a respectable library of scripts that can be used to detect and validate vulnerabilities. NSE scripts range in functionality from brute force and authentication to detecting and exploiting vulnerabilities. For our purposes, we'll focus on the scripts in the vuln and exploit categories, as the former detects a vulnerability and the latter attempts to exploit it. However, there is an overlap between these categories, and some vuln scripts may essentially run stripped-down exploits. For this reason, scripts are also further categorized as safe or intrusive. We should take great care when executing the latter because they may crash a remote service or take down the target. On Kali, the NSE scripts can be found in the Nmap scripts directory. This folder also contains a script.db file that serves as an index to all of the scripts. It also categorizes each of the Nmap scripts. We could, for example, use the file to grep for scripts in the vuln and exploit categories. Let's try to use an NSE script to detect a vulnerability. For this example, we'll use script vuln to run all scripts in the vuln category against a target in the labs. We see that one of the NSE scripts successfully detected an Adobe Cold Fusion vulnerability on our target. This is rather interesting and worth further investigation. While Nmap is not a vulnerability scanner in the traditional sense, it can be very useful for similar tasks. However, Nmap also requires heeding the same warnings applicable to traditional vulnerability scanners. We must understand what the scripts will and will not check for, the amount of traffic the scripts will generate, and what potential dangers we may incur with each script. Wrapping up. Vulnerability scanning can be very helpful during the initial phase of a penetration test. Once configured correctly, vulnerability scanning tools can provide a wealth of information and reveal some serious and unforeseen vulnerabilities that can have a significant impact during a penetration testing engagement. That being said, it's important to understand that a manual review is still required, and that scanners can only discover vulnerabilities that they're programmed for.